Okay, so this is the first section of our notes, guys. So this is chapter 1, functions and their graphs. The first section is called lines in the plane. So this should be a lot of review from integrated math 1, how to find the slopes of lines, how to write equations given points on lines and their slopes. Use slope-intercept form of linear equations to sketch lines, and use slope to identify parallel and perpendicular lines. So the first thing we need to start with is a definition of slope, which a lot of you guys should already know. So in general, the slope of a non-vertical line represents the number of units that a line rises or falls vertically and, excuse me, not and, for each unit of horizontal change from left to right. Okay, so in general, if we have a graph, so if you just draw a simple XY axis, okay, then I have 2 points. So I'm going to call this one X1, Y1, and then a second point. We're going to call this X2. It's going to be Y2. And we draw a line through those points. Okay, the slope is going to represent the distance that this changes horizontally and vertically. So the distance between here and here, we can say Y2 minus Y1. And then the distance between here and here, we can call X2 minus X1. So the slope is represented by the ratio of these two things. So Y2 minus Y1 is the change in Y. And then X2 minus X1 is the change in X, which means that the slope M is equal to the ratio of the two things. So Y2 minus Y1 over X2 minus X1. So please put a box around this, highlight this, because we need that definition. So for our first example, oh, excuse me, not yet. We're doing types of slope. So in general, there are 4 types of slope. We have a slope that is positive, rises from left to right. A slope that is negative falls from left to right. A line with 0 slope is horizontal, and then a line with undefined slope is vertical. So if we want to visualize it, positive slope is going to look like this, where it's going to go up from left to right. Negative slope is going to look like this. 0 slope is a horizontal line, so it's flat. So it's going to look something like this. And then undefined slope, it's going to look like this. Instead of a horizontal line, this time it's a vertical line. Looks something like that. Where's my mouse? Okay, so example 1. So we're going to find find the slope between each pair of points. So for part A, I'll give you guys the points -2, 0, and then the point 3, 1. So the slope, the formula is y2 minus y1 over x2 minus x1. And it's a good idea to label your points. So if this is the first point, we can call that x1, y1, and this would be x2, y2. So if you just substitute it in, you get 1 minus 0 over 3 minus -2, which is the same thing as 3 plus 2. Simplifying, you get 1 over 5, and that does not simplify anymore. That's our answer. For B, we got -1, 2, and 2, 2. So m is equal to 2 minus 2 all over 2 minus -1, same thing as 2 plus 1. Simplifying, you get 0 over 3, which is 0. For part C, 0, 4, and 1, -1. So m is going to be equal to -1 minus 4 all over 1 minus 0, which is going to be -5 over 1, which is -5. And we're out of space. So for part D, we're going to do -3, 4, and -3, 2. So the slope is going to be 2 minus 4 all over -3 minus -3. Okay, on the bottom here, you notice that they're the same numbers. So what's going to happen? 2 minus 4 is -2. And then -3 minus -3 is the same thing as -3 plus 3, which is 0. Okay, whenever there's a 0 on the bottom, the slope's not 0. Remember, we can't divide by 0. So m is undefined. Okay. Point slope form. So definition. Okay, if you want to know the equation of the line, so given one point and the slope, we can find the equation of the line. We can find using point slope form. So point slope form is going to be y minus y1 is equal to m times x minus x1. So put a box around this because you guys need to know this. So example 2, find the equation of the line that passes through the point. One comma -2 and has a slope of 3. Okay, so here the slope they give us is 3, and then the point they give us is 1 comma -2. So point slope form, if we want the equation of the line, y minus y1 is equal to m times x minus x1. Okay, so what we're going to do is this right here, the point they give us is the x1, y1, and then the slope obviously is m. So the y and x stay the same because that represents any point that also exists on the line. the x1, y1 is the point that they give us. So we need to substitute these two numbers in for y1, x1, and the m is 3. So y minus y1, so y plus 2 is equal to 3 times x minus 1. So if we simplify, y plus 2 is equal to distribute 3x minus 3. And if we move that 2 to the other side, y is equal to 3x minus 5. So this is the equation of the line. This is the slope-intercept form, which we'll get to here in a second. But your homework, what's going to ask you is to find other points that exist on the line. So that means that we can pick any three numbers to substitute for x to find another y value. So make your life easier. So let's use 0 to start with. So if x equals 0, then y is equal to 3 times 0 minus 5, which is negative 5. So that means that 0 comma negative 5 is a point on the line. We already used 1 because that's what they give us. So let's use 2. Y is equal to 3 times 2 minus 5, which is 1. So 2 comma 1 is another point on the line. Then if we pick negative 1, y is equal to 3 times negative 1 minus 5, which is negative 8. So that means that negative 1 comma negative 8 is another point on the line. Okay, slope-intercept form, which we all should know. The graph of the equation y is equal to mx plus b is a line whose slope is m and y-intercept is 0 comma b. Okay, so we're going to practice graphing using slope-intercept form because it's something that we should know for this class. So we're going to do 5 graphs. So for the directions, determine the slope and the y-intercept of each linear equation. Then, sketch the graph. Okay, so for part A, x plus y is equal to 2. So the easiest way to graph these is in slope-intercept form. So what I'm going to do is I'm going to rewrite this in y equals mx plus b form. So to get y by itself, I'm just going to subtract x from both sides. So if I do that, I'm going to get y is equal to negative x plus 2, which means that the m is negative 1 and the b, the y-intercept, is 2. So if I want to graph this, then I'm going to do is, since this is my b, I'm going to start on positive 2. The slope is negative 1, so remember rise over run, so down 1 to the right 1. So if I go down 1 to the right 1 and plot another point, and then do it again, and I could keep doing that forever if I wanted to, but just a few points is fine. And then using a ruler or straight edge, graph the line. For b, y is equal to 2. So here, notice that there's no x, so that means that the slope is 0, and that means the y-intercept is 2, because we could rewrite this as y is equal to 0x plus 2, because remember 0x, that's just 0. So that means that the number in front of the x is still 0, so the slope is 0. So this is one of those unique situations that students tend to forget about. I'm going to do it this way. So if I want to graph this, since the slope's 0, the y-intercept is 2, I'm going to draw a point at 2 on the y-axis. And since the slope's 0, that means there's no rise and there's no run. So I can just draw a horizontal line. Oops. A horizontal line through those 3 points. Okay, for part C, we're going to do 1/3 y minus 2x is equal to 1. Okay, so get y by itself. So moving the 2x to the other side, you get 1/3 x is equal to, sorry, 1/3 y is equal to 2x plus 1. Multiplying everything by 3 to get rid of the 1/3, you get y is equal to, if I multiply this by 3, I'm going to get, 6x plus 3. Now to graph this guy, the slope is 6 and the y-intercept is 3. So plotting a point on 3 on the y-axis, and then the slope 6, so going up 6, 1, 2, 3, 4, 5, 6 to the right 1, and plotting another point. And then we have our line. For D, we're going to graph 3x minus 4y plus 8 is equal to 0. So we want to get the y by itself, so I'm going to move the 3x and the 8 to the other side. So negative 4y is equal to negative 3x minus 8. Dividing everything by negative 4, y is equal to 3/4 x plus 2. Okay, so this y-intercept here is 2, and our slope is 3/4. So y-intercept's 2, slope's 3/4, 1, 2, 3, 1, 2, 3, 4. And I could do that again if I wanted to, but I think we know what we're doing. So here we go. Okay, last one I want to show you guys is what if we just have x is equal to negative 3? Well, here's a unique situation because there's no y. So in this case, this represents the graph of a vertical line, which tells us that the slope is undefined, which means that the y-intercept also does not exist. D and E stands for does not exist. So to graph this, all this means is on the x-axis, we're going to draw a vertical line that just goes through negative 3. So we're going to plot a point on the x-axis at negative 3, and then we're just going to draw a line that goes vertical straight up and down. Through that point. Okay. All right, so summary. So you guys are aware there's technically 5 types of lines that you guys need to know for this class. So the forms that I want you guys to know is this one, the book has you guys learn, and it'll come up in your homework, but it's general form. So this is the form ax plus by plus c is equal to 0, where a and b cannot be 0, cannot both be 0, and a has to be positive. For the vertical line, that's the equation of the form x equals a, where it passes through the point a comma 0. And then here you want to know here m is undefined. Third one is a horizontal line. So since we use a already, we're going to use b this time. So this is the form y is equal to b, where the line passes through the point 0, comma b. And so you guys have in your notes here, m equals 0. Next one, slope-intercept form, which our Math 1 teachers probably ingrained into our brains. This is y is equal to mx plus b. Okay, we need to know this. There's no excuses not to know this by now. So where m is the slope and b is the y-intercept, and when all possible, use this form to graph. 5, point slope form. So because this is pre-calculus, you guys will see this again in calculus. This form comes up a lot to find the line tangent to a curve, but it's y minus y1 is equal to m times x minus x1. Okay, so you want to use this as a reminder, use this to find the line, the equation of a line, given one point and the slope. Okay. So we have one more definition for these notes, and it's parallel and perpendicular lines. Okay. So the definition for that. So number 1, two lines are parallel if and only if they have the same slope. Oops. Two lines are perpendicular. And just to save you guys time, perpendicular, you can abbreviate using this upside down capital T. If and only if, and that can be abbreviated IFF, if and only if, their slopes are negative reciprocals of each other. So that is if m is 3, the perpendicular slope would be, the reciprocal of 3 is 1/3, but then you change the sign. If m is, I don't know, 7/2, then the perpendicular slope would be -2/7. So you just take this guy, flip it upside down, and then change its sign. So if it was negative, now the perpendicular slope will become positive. So doing an example. So we're going to find the slope-intercept form of the line that passes through the point 2, -1 and is parallel to the line 2x minus 3y equals 5. So the first thing you're going to do is you want to rewrite this guy in slope-intercept form, because if I want a line that's parallel, then we need to know what the slope is. Parallel lines have the same slope. So getting y by itself, -3y is equal to -2x plus 5. Dividing everything by -3, y is equal to positive 2/3 x, and then minus 5/3. So we want a line that is parallel to this line, but goes through this point. So that means that we want a line that has the same slope as this line to be parallel. So that means that if it's parallel, then the slope of the parallel line is going to be 2/3. And then the x1, y1 is going to be 2 comma negative 1. So now we're going to use point slope form to find that line. So y minus y1 is equal to m times x minus x1. Substituting everything in, y plus 1 is equal to 2/3 times x minus 2. Distribute, y plus 1 is equal to 2/3 x minus 4/3. Moving the 1 over, y is equal to 2/3 x minus 7/3. So this is our answer. Now, for this problem, we're going to use the exact same line. So find the equation of the line that passes through the point 2 comma negative 1 and is perpendicular to the line 2x minus 3y is equal to 5. Okay, so I did us a favor here, and I'm using the exact same equation as before. So this is going to be in slope-intercept form, the same thing as the one we did in the last example, because it's the same line. So if we go back, y was equal to 2/3 x minus 5/3. So here, the slope is 2/3. So if we want a line perpendicular to that, that means that we need the negative reciprocal of 2/3, which is negative 3/2. So we want a line that passes through this point that has a slope of this. So here for our line, for the new line that we need, the slope is going to be negative 3/2. And the x1, y1 we're going to use is 2, negative 1. So y minus y1 is equal to m times x minus x1. So y plus 1 is equal to negative 3/2 times x minus 2. Distribute, y plus 1 is equal to negative 3/2x. Negative 3/2 times negative 2, the 2's cancel and the negatives cancel, so you get plus 3. And moving the 1 over, y is equal to negative 3/2x plus 2. So this answer was a little bit prettier than the last one. Okay, last example. So Thomas buys a car for $27,000. In 5 years, the car is worth $16,000. Write a linear equation that gives the value V of the car after T years. Okay, so even though it doesn't look like it, this is similar to what we've been doing the whole period or this whole lesson. So if you buy a car and initially for $27,000, 5 years later, this is what the car is worth. So at the beginning, no time has passed because when you buy the car, no time has passed. So at time zero, we can write as a point. 0, comma, the car is worth $27,000. So this is at year 0. And then in year 5, you can think about that as 5 years later, the car is worth $16,000. So we want to write a linear equation. So if you think about it, we want to find the slope between these 2 points, and then we can use point slope form to find the equation. So to find the slope, remember y2 minus y1 is equal to x2 minus x1. So my y2 could be 16,000. If you want me to label it, this would be x2, y2. This could be x1, y1. So 16,000 minus 27,000 all over 5 minus 0. Simplifying, you get negative 11,000 over 5, which is negative 2,200. So this is our slope, okay? Because we want the line that passes through both points, it doesn't matter which point you pick to write it in point slope form. So because this point has a 0, I'm going to use this guy. So I'm going to say, to write in point slope form, y minus y1 is equal to m times x minus x1. So my y1 is going to be the 27,000, and the x1 is going to be our 0. And then the slope, we already know, is 2,200. So y minus 27,000 is equal to negative 2,200. Oops. 2,200 times x minus 0. So y minus 27,000 is equal to negative 2,200x. And then if I distribute this, 0 times anything is 0, so we don't write anything over here. Moving this to the other side, you're going to get y is equal to negative 2,200x plus 27,000. Okay, this would be our answer, but we have to be careful because the question says write a linear equation or function that represents the value v of the car after t years. So instead of writing y, I'm going to say v is equal to negative 2,200 t for time plus 27,000. And we are done with 1.1.